Good morning, happy April 1st. Hopefully you've played some fun practical joke. So this week we're going to work on some additional tools than in Python. Today, on Thursday, we're going to look at some possible solutions for last week's homework where we edited a program, which is a really important skill, is to be able to look at what's existing, make some changes, and be able to make it more usable. And that's one of the strengths of Python, is it looks so much like English that you can grab an existing program and modify it fairly easily. So we're going to learn how we can create an index and slice a list up. So a list is an idea we're going to introduce. How we can take elements in and out of a list. What other methods we have to sort a list, because a lot of times we want information in a list versus just a single item. How we can work with pairs of data. So this is a technique that, had we known about it ahead of time, we could have changed our program from last week. And in fact, a couple of students actually did go back in, looking ahead, and said, hey, I can use a dictionary item to create a paired list. So what we're going to start with is the idea of something like a hangman game. So we've all played hangman. We know what it's going to look like. So if I run this, so far we have these letters used. The word is 4 letters long. So if we enter an E isn't in the word. And we're getting nowhere. So, and notice how it's building this hangman as we go. Oh, we're done. And we got killed. So, very quick little hangman program. And we're starting to make a graphical element. Now, granted, this is text art, but we're starting to get some kind of a graphical piece into our software. So, one of the differences between a list and a tuple is that ability for a list to be modified. And so we can modify them on the fly. So depending on what we're using, we may want to use tuples or we may want to use a list. So on page 124, we start creating a list. So in this particular case, it's going to look very, very similar. So we're going to go back into, and we're going to look at another version of that heroes inventory. And so here we're going to create a list. So we're creating a list called inventory. And that inventory, so if we just have this portion, we're going to put in a sword, armor, shield, healing potion. So this particular piece then says print your items, and then every item in there. So for item in inventory, in other words, we're going to go cycle through that entire inventory. We're going to print that item out. So if I run just this first portion, so we run, so notice it lists all the items: sword, armor, healing potion, etc. And we could add in an additional piece. So you could say, well, all right, I need a invisible cloak. And so we've created this piece. Well, we may want to find out that length of an inventory. So that length function, remember, if we're doing a length of an individual variable, shows how many characters are in a length. If we do the length of a list or a tuple, it tells us how many items are in that list. So it's kind of a handy tool for that. So this will give us this next portion. So we're printing out you have length of the number of items in the inventory. So let's run that again. Okay, so there's our number of items that are in there, so we can count them. 1, 2, 3, 4, 5. Okay. We're going to go to the next step. So we have 5 items in our possession. So it simply gets a length of that particular inventory, which we can then use in our program. So next, we're just doing that very quick test. And this is one of the powerful things in Python is we can search through an inventory or a list or a tuple or a sequence very, very quickly, and we don't have to write any code for it. It's all by default in here. So we can actually look. So if healing potion is in inventory, on only if it'll print you will live to fight another day. Now we can modify this and put in an else. So you will die a horrible death. And again, all these print statements, those are actually a function. You're calling that print function. So I'm going to close this one really quickly. Yes. And so if I run this now, and it'll make us save it, run module, yes. So it says we have these 5 items. We have 5. The next piece, you will live to fight another day. Okay. So if we took out of our inventory then, so we can double check that. So our inventory, we can take out healing potion. So we're just going to take it out, make sure our clause works. And so one of the things when we build this code is if we do these kinds of things, we test as we go. You don't end up at the end of your program and go, oh, this doesn't work. The other thing, we really, really, really need to create a structure before we get to that point. So we're going to save it. So now we only have 4 items, obviously. So 4 items in our possession. Press the enter key. Sorry, you will die a horrible death. So our search through our, let's put that back in. Healing potion, comma. And so we can have as many items as we want in that list. Now we've run it back up to our 5 items. We tested to see if you're going to live or die. Well, now we want to start doing something a little interesting with that. We know how many items are in our inventory. So we can look at it and we can index a list. So in other words, we know which each piece is. So we're going to use the index, and so we assign it index is equal to whatever the integer input, and remember that's a handy way to combine those. So you can do an input. It changes whatever you do into an integer. So if they enter in a B or an A or some other character, it will try to convert it into an integer. And then we're going to print at index, whatever our number was, is inventory : index. So again, it looks very, very similar to what we did with tuples. So let's run the module. Okay, yeah. So go through the first couple pieces we did. So enter an index number. So let's enter 8 and see what happens. Aha! So we have an issue still in our program because we didn't have any kind of verification to make sure it's in our index, but we'll go into that error trapping here in the future. So run. All right, so we know then we have 5 items. So an index number then, so if I put in 5, look what happens. It crashes because that index counts with 0. So let's do it one more time. Five items again, nothing's changed. Enter an index number. Well, let's go 3. We know that's in our range of 0 to 4. At index 3 is a healing potion. Okay. So if I look through and I come up to my inventory, 1, 2, 0. So 0, 1, 2, 3. Now it's really the 4th item in our list, but we start counting with 0. So we can do that. So our next thought, well, if we have the ability to get an index, can we slice a piece of that? Well, let's see what happens. So this particular piece here, so start, we're going to enter the index number to begin a slice. Finish, the index number to end the slice. Okay. So we're going to print then the start number and finish number. And we're going to print the inventory of that slice. So let's run this one more time and see what happens. Okay, so we know we're here, index number 3. Okay, oops, scroll that up so we can see it. Okay, enter the index number to begin a slice. So let's pick 2 to end the slice 3. So the inventory between 2 to 3 is shield. Okay. So let's come up here and look at that again. So the slice 0, 1, 2. So between 2, beginning here, and 3 is that name of shield. Now we can run it again and look at a couple of other ones. So we run again. Chunk, chunk, 3. So let's see if we go from 1 to 4. And notice there when I go between 1 and 4, it pulls out armor, shield, and healing potion. Great. So we can slice up this list just like we did before. We can concatenate a list. So let's look again. So concatenate means we just put together. So if I look here, we're going to create an item called chest, and it's going to have 2 pieces in it, gold and gems. Okay. You will find a chest which contains, and so you're going to print that list, and you can add the contents of the chest to your inventory. So you're going to take inventory and add the contents of chest. Okay. So let's see if this works. We're going to take what happened to be starting in here, and we're going to add that back in. So we'll run that again. We'll just pick our 3 and we'll do 1, 4. Okay, so our next step then, we found a chest that had gold and gems. You add the contents of your chest to your inventory. Your inventory is now, so when we printed out inventory again, now it includes gold and gems. Interesting. So we can concatenate 2 lists and put them together. Now, Where we differ, so far this has looked a lot like what we did before. Here's where it looks like we can change things. So we can actually put in an element by index and change that element in there. And this makes it very handy. So if I want to change the element 0, so come back up to my list, so element 0, so a sword. Well, I want to trade that sword for another item. So in this case, we're going to trade it for a crossbow. This allows us then to assign an element back in. So inventory bracket 0 is now assigned the value of crossbow. And then when I print out inventory, it's going to show that that's changed. So I have this still open. I'm going to hit enter to run that. So you trade your sword for a crossbow. And notice now when it prints out that inventory, it's changed. So as our program goes on, it can change that inside of a list. We can delete an element. So now this is new. So we haven't used the delete function yet. So in a great battle, your shield is destroyed. So delete inventory item 2. Now, I want to point out something interesting here. So let's look at what happens. So I've got this open still. So our next step is we're going to hit continue again to see if that lines of code ran. So use your gold in games to buy an orb of future, blah, blah, blah. Your inventory is now. Notice. Oop, hang on, where's my deleted? Hang on, close that out. Okay. So this deleted item here will delete that inventory piece out. So it's going to delete inventory item 2. Now when that happens, so 0, 1, 2, so it's going to delete shield. When that happens, everything to the right of that in our list, or past that point, gets renumbered. So you have to be cautious when you use that. And see what happens. So. This assign by slice works the same way. So inventory, we can create an inventory that is multiple items. So we can delete by slice. So in this particular case, there's an additional shortcut here. So we didn't put 0 through 2, we just put colon. We can shortcut that. And it's going to delete the very first items. So let's go through and run a couple of these so we can see what's going on. So run. Okay. We start out. Well, we know we can take a slice. Yes. So you added the golden gems. We now traded our sword for a crossbow. So now our inventory is crossbow. We bought an orb of fortune telling. So notice here, we started where healing potion was. And now if I look at that, let me stretch that out a little bit so it's easier to see. So if I compare those two lists now, notice what it did. It replaced orb of fortune telling, replaced invisible cloak and gold. So notice that difference there. So that's worth replacing by the slice. So let's continue on. Your shield is destroyed. So now, notice here's my inventory. So crossbow, armor, shield. Now that shield is just gone from that list. Oh no. Now our crossbow and armor are stolen by thieves. So at that point then, now our list is just this set of items here. So if we did a length at this point, now we would only show 1, 2, 3 items. So this is a change from how we could work with a tuple. So tuples are not mutable. In other words, they're not changeable. So I want to go look at, I'm going to go backwards a chapter, and I want to look at the difference. So I can open these two up and look at them side by side. Because what I want to look at is the difference here in this inventory. So I'm going to copy this. I'm going to put it right below there just so we can look at them side by side. Oop. Because they look very, very similar. The only difference when I create these, so I want a list that's mutable, in other words, it's changeable, or I want a tuple that's not. Look at this only difference. I put a quote mark or a parenthesis for a tuple, and I use a bracket for my inventory. And that's pretty subtle, but how they behave can be variable, very, very different. So make sure you've worked through and looked at how those work. So no, not going to change it. Okay, so that gives us the ability to create a list that we can change on the fly. So one of the things we might want to look at is something like a high scores. So, a high scores program. Well, let's look at our original high scores. So I'm going to edit this, and we're going to look at and see what's going on there. So let's just run it and see what happens. So run module. So high scores. So we have a couple of things. So we've got a menu item now we've created. So we can exit, show scores, add a score, remove a score, sort scores. So all kinds of things now we're going on in here. So let's show scores. So I'm going to hit choice 1. And right now we don't have any scores. Okay. So let's see what happens then if we add a score. So 2. What score did I get? 100. So let's add a couple of scores. So maybe this is a bowling, and sadly that's close to my bowling average. No, it's not that bad, but it's not good. So now we can show scores. So let's look at scores. I show them, and notice now it's created a list, and I can show those scores. So I'm going to add another score. So I want to make sure it really does work, and I'm going to add a 44. Got a lot of gutter balls. So I want to list those. So let's go to 1 and show scores. So 100, 101, 103, 44. Well, I have a little OCD problem, so I want to make sure that I have those sorted. So let's hit 4. And then let's show scores and see if that did sort them for us. And notice we start from high all the way down to low. Great. So a couple of things that I want to point out about this program. Notice how it keeps going. It iterates over and over again. We've created this menu item, which is a new idea or thought. In other words, we can keep our program open and do multiple iterations through it. It gives us this choices. And so let's see if this program, and let's see what happens if I put 5 in. Oh, we've put in some error trapping. Let's put in a letter. Sorry, but A isn't a valid choice. So we've started to restrict what we have going on. So what we've done is put our entire program in a loop. And inside that loop then, now we're running this program here. So notice the entire program is in this loop that will run as long as our choice does not equal 0. So as long as I don't hit 0, this program repeats. So I hit 0 and it exits. So we put our entire program in a loop. Okay. Well, that's kind of a new concept. Inside of that loop, then, we have exits. So we know that loop, what's going to happen when it jumps out. So we can put a set of if-then statements. So if choice is equal to 0, well, the loop isn't going to run a second time after that. So we're going to put in 0. So we input 0 right here. Input our choice. It's going to have 0. It's going to then come down to the bottom of this. It's not going to run any of the other elifs or the else. And it's going to stop here. So that loop isn't going to repeat. Well, then we have, because we have multiple choices, we can use those elifs. So elif choice equals 1. We're going to print high scores. If it's 2, we're going to create a score input method. We'll go back and look at these individually. If it's remove a score, well, that's choice number 3, and we didn't use that yet, so we're going to look at how we pull that out. We're going to sort scores, and then if it's something else, anything else other than those choices, then we print, sorry, but your choice isn't a valid choice. Oh, okay then. So let's take a look at these individual pieces then. So we created a menu. 0, goodbye. That's pretty self-explanatory. The printing of our high scores. So elif choice equal 1. We're going to print high scores. And then we just create a for loop inside of here. So for score in scores, print score. Okay. So notice here we created a blank list called scores. And individually inside of there, each item is a score. So we're printing score out of scores. Okay. If we want to add a score, so now score equals your input, and we convert it to an integer. So even if you put in ABC or something silly, and then it uses, so it references scores. So we created that list, and we use the dot append. And then into that function, we pass the value score. So we assigned it a value here, which you input. Here we're passing it back into the append function as a dotted notation of scores. If we need to remove a score, so option 3, so score equals, again we use that same kind of technique. We took an integer of whatever our input is, and then first we check to see if that score actually exists. So if score in scores, if that's true, so in other words, we'll run this line. So scores.remove score. Amazingly easy in Python compared to other languages. Else we're going to print whatever score you typed in isn't in the high scores list. And we'll demonstrate that and show you here. So the last piece, and so in most programming courses we teach you all different kinds of sort methods and how to create one from scratch. Well, Python has a pretty robust, fairly good sort built in. So we don't need to necessarily do that. We can, so if it's number 4, all we have to do is call the .sort routine. Now, this reverse equals true. If I didn't have that in there, what would happen is it would actually create a list from smallest to largest in ascending order. And what we want to do is create it where it creates a list that goes from highest to lowest. So on the bottom of page 132, there are a list of some methods that you can use. So the append, the sort, the reverse, so we can actually flip a list, which is interesting. It doesn't sort it, it just flips it from end to end. Kind of an interesting option. Insert, and then pop, and then remove. So all those are very interesting choices. And so none of these have we seen before, because with tuples we couldn't use the ability to change those things on the fly. So let's look at this again. So we're going to run this. And so let's add some scores. So 2, and I had a really good day. So I'm going to add another one. And then I'm going to add one. Well, so if I show scores, apparently I got tired, my arm got sore, my bowling scores went downhill dramatically. So they're already in order from highest to lowest, so I don't necessarily need to sort them. But I don't want everybody to see that score that I have. So I'm going to click Remove a Score. And I'm going to remove my score, but I mistyped. I typed 66. Oh, it says 66 isn't in the high scores list. Okay, I messed up. So I'm going to put 3, remove a score. And so now if I showed those scores, notice it only shows those 2 that are handy. Well, that's pretty handy. This gives me a way I can keep my scores, and we can start introducing some other functions. We could pull all these through there, and we could do an average, and we could do a lot of other things. But for now, all these new functions are where we're looking at. And if you're starting to look at this and think, well, this is a way I could have done the assignment, yes, it is for last week. So why do I use tuples? Why do I use lists? What's the difference at all? Well, there are times that we want to have a list of items or an item that we can't change, or very close to a constant. So those are good. That means they can't change in the running of the program, and so sometimes we use it for that purpose. In very, very large programs, tuples are faster. And so when we look at dictionaries, for example, you'll see that we have to use tuples. So most of the time, though, I'm going to tell you that lists are what we want to use, because we do have that ability to loop through them, change them, modify them on the fly. And so that ability to change is pretty important. So I'm going to close this out of my way. So on the bottom of page 133, we introduce High Scores program number 2. So we made one little change. So these are all my bowling scores. Maybe I want to keep track of scores for other people. So I may want to keep track of who got a high series, who got a high game, and I want to add some names to this. So I am going to, and before we even look at it, we're going to run this program and see what it does. So High Scores 2.0 has less options. Interesting. So if I list scores, a name and a score. Well, let's add a score. What is the player's name? What score did I get? So let's add another score. And John got, sorry, it's down at the bottom here, a 450. So let's list scores. And so now we can list them, and it's got a name and a score. So what are we doing? How are we joining a name and a score together? Well, let's take a look at some of our code here and see if we can figure out what's going on. So, again, we have this menu. So we have the entire program inside of a while loop. So it goes down to here. We set scores to a null, and it's we created a list. Notice that it's blank. Good practice. We just made it blank. Choice equals none. Okay. So, again, we have a print statement just to start out. And we have a choice. So we input choice. So, just like we did before. Here we create an if statement. So if choice equals 0, goodbye. So that is very, very similar to what we did before. So here we have an elif for if choice equals 1, in other words, our high score. So it's going to print high scores, print name, tab, score. And for entry and scores, score comma name equals entry. Now that is different. So notice what it's doing. It's printing name, a tab, and then a score. Interesting. So notice then if we add a score, let's see what happens there. Maybe this will give us a little better. So if our choice is 2, name is assigned the value of input for player's name. Score is what score did the player get. But then entry equals score comma name. In other words, we're doing something called nesting a sequence. Oh, you mean we could have done this or something similar? Yes, we could have done that. So here we have scores.append entry. So in other words, we're passing entry into scores. And notice it's passing 2 values, score and name, into one list. Scores.sort reverse equals true, so it's going to do them by high score. And scores equals scores colon 5. So in other words, we're slicing out 0 through 5. So we're only keeping the top 5 scores. So let's look at that and run it and see if that is actually the choice. So let's add a score. Mike, and his score was 123. So now we know if I listed those, I'll have 3 of them. So we'll add another. So, and Missy got a 467 or 76. We list them. Now we have 4 names on the list. So Margie, and she got a, oh, I guess we have to add a score, not put her name in first, Margie. And she got a 567. So we list our scores, and now we have 5 scores in our list. Well, let's see what happens to poor Mike there if we enter another score. So Kelly, want to get ahead of myself here. Okay, so add a score, Kelly, and Kelly scored a 124. So now let's list our scores. Wow, and we just slapped Mike right off of the list. So this is another technique. We create this idea of nested elements. So we're printing out all these items, and they're really stored in a nested fashion in there. So this is element 0, element 1, element 2, element 3, element 4 in our list, if we start counting at 0. Now, we can create these many levels deep, but you don't want to probably go more than 2 or 3 levels because it'll get very confusing. So once we have these elements, how do we access them individually? So we can actually access an element directly inside of there. So as we did here, so print for entry and scores, we're going to print name, comma, score. And what we did though, notice how we pulled that back out of there. Because we know this is a nested element with 2 items, we assign score, comma, name back out of entry. If I would have just printed entry, and so let's see what happens. Let's change this to just print entry and see what happens. Yes. Okay, so we'll have to add a score. Alright, so now if I list scores, let's see what happens. So it shows me, it printed out 1, 2, 3, comma, Mike. So it shows me that it shows that entry, and notice if I would have had more of those. So this is kind of a handy thing we can do to be able to pull those back in and out of there. So we have to keep track of how we've created those nested ones. So in that data dictionary, we can do that. Now, we can access pieces directly. So I could use, if I know that there's already elements in there, and this one we created it on the fly, but I can use something like this. So we can access an element directly. So I could create entry and in whatever position. So whatever's in position 3. But if I want just the individual piece in there, I can do something also. So I can set another bracket in, and I just wanted the first piece of that. Now, this isn't going to return anything yet until I had a value in there. So it's going to return the third nested item, and it's going to return the 0 position of that item. So in other words, we're putting a list inside of a list. And I know that's a little confusing, but it's a handy technique we can use. So we can print pieces and we can assign them internally that way. We can pull pieces in and out of our list this way. So if I really wanted to, I can also assign values this same way. So if I didn't want to assign a high score, I just wanted to assign a name, I could use the equals entry position 3, comma 0, so I wouldn't necessarily have to do that. So make sure you work through these in the book. So on page 138. So this program, make sure you've looked at it. Nope, don't want to make any changes. Want to close this out. Yes. So on page 138, we start looking at something called a shared reference. So a shared reference is kind of an interesting thing. So the book uses a weird example of if I'm at a party, people might call me by different names. So if I think about my own children, they call me Dad. Other people call me Mr. Griffin. My girlfriend calls me, well, usually Brad, a few times other things. So all of those refer to the same thing. They refer to me. But maybe I want to refer a list to multiple items. So that way, no matter which one of those names I'm called by, I can use that. So make sure you read on page 138 the shared reference, because we're going to utilize it in some upcoming pieces. So what I want to look at last today is something called a dictionary. So a dictionary is a specific kind of group of items, so where we have a term and a definition. And we use it quite often. So in Python, there's actually a completely separate item list for those. So I'm going to look at this program called Geek Translator. And so we're going to run it first, and we can see what it looks like. So let's look up a geek term. So what term do I want to translate? So nerd isn't in there. So we know that maybe we'll need to add a nerd in there. So let's see what other terms are in there. So if nerd isn't there, let's see if geek is. So I want to look one up. Geek. I don't know geek. Well, let's cheat and let's look at our program. So Googling, keyboard, link rot. Let's look at 404, just because it's the least typing I have to do. So 404. And notice it says 404 means clueless. From the web error message 404 meaning page not found. Interesting. Well, we have a couple of other options in here. So we can add a geek term or redefine a geek term. So let's look at, first let's adding. So let's add a geek term. I want to add nerd. And our definition is we're going to add that in. So now if I look it up, nerd means your instructor. Interesting. So we can redefine one. I want to redefine nerd. So now if I look it up, notice it's changed. Nerd means, it really means a super smart person. Great. So let's look at a couple of these things in there. So there's a couple of changes that happen. So let's look at our program. So up at the beginning, let's take a look at this. So this is a little interesting. So scroll up here. So notice we defined some kind of variable called geek. And that geek has a list of items. So it's got 404. Oh, no, wait a minute. Now that's different. Notice how it's got a colon there. So 404 colon, and then our definition, comma. And then Googling colon. So it's structured a little different than we've looked at before. So we'll take a peek back in there. So we do the same thing. So we create a while loop. So while choice is not equal to 0, and we create this list of what our items are. And then we have at the bottom our unknown choice, so if it's anything else. So the same basic structure. And what I'd encourage you is maybe to create a template file with this basic structure in it, and you can utilize that over and over again. So we want to get a definition. So if choice equals 0, goodbye. That one's pretty standard. So if choice is equal to 1, we're going to get a definition. So we're going to input a value called term, and it uses that input, very similar to what we've done before. And then we ask if it's in the list or dictionary called geek. If it is, so if term exists in geek, and it will search through there, that definition then equals the value of geek with the index of term. So instead of a numeric value, the dictionary uses that first item as its index. So that's pretty slick. So it looks through there and all the index pieces to see if geek is there. So, and then it prints out term, which is our value here, means, and what the definition is. And that definition is what we assign there. If it doesn't find that value in there, then it prints out, oh, I can't find it. So we do the same type of item. So in other words, we don't have to remember a value. What we can use then is this term becomes that index. So same way if we want to add a new one. So if we add one, we get choice 2. So term equals our input. So if term is not in our list of items, so if it's not in geek, so everything else we've done so far has been if it exists in, well, here we have a negative, so term not in geek. So in other words, we want to look through that list and only add that item if it doesn't already exist. So then we have definition then equals input. So we have a term, an input, and now we assign geek with the index of whatever we typed in and the definition in one piece. So it works very, very similarly, except that index has changed. So if it already exists in there, so if we tried to redefine 404, it would say, nope, you can't do it. This says if it exists, so if it already exists, so we're going to redefine one. Definition equals the input, and here we put it in. So we're just overriding what's actually in there. Well, we do the same thing here. Now we're just deleting. So if we have the choice to delete one, again, very similar structure. Our term equals input. We're deleting that entire term. and we delete whatever's in that value at the index of whatever we've input, and we're out. So if it's anything else. So this is just a quick, handy way to build a dictionary internally in our program. So we can test for it. So on page 143 at the very bottom, there is another retrieval method. So here we used something similar. We have a dot notation method. So on the bottom of page 143, make sure you look at the get method. So there is a method there. So page 145 talks about adding those key pairs, 146 replacing and deleting, and then wrapping up the program. So couple of things. Dictionary has to have separate item keys. So if I tried to put in two of the same thing, that's one of the reasons we check through it first. So on the top of page 148, it looks at that idea of a dictionary method. So make sure you've read through the rest of the chapter. We'll talk about the Hangman program, how we utilize that to create a program like that, and what kind of items are in there. So as you can imagine, we probably use dictionary items. We introduce the idea of some constant values. So we're going to look at this again and all these items, but you have to be working through there. All right, on Thursday, we're going to look at this game. We're going to look at some possible solutions. And for last week's assignment where we edited code, the reality is there should be as many different ways to edit and modify and utilize that as there are students in class. So one of the great things about Python is this ability to modify code on the fly. And because it looks so much like English, so when I look at this, it looks almost like our pseudocode. It looks very English-like. It's not hard to decipher what's going on in most cases. It's even better when we put in as many of these documentation terms as possible. And so those are kind of handy even for ourselves to keep track of our program as we go along. All right, I hope you have a great April Fool's Day, and we'll talk to you again on Thursday.